Ladies and gentlemen, I'm back. Mason here. And yeah, it's the night time, and keeping my word that I will upload this shit today. I have basically done nothing. No, just joking. Yeah, I have sucked a lot of. Basically, I have been struggling with this shit lately. Let's say these little guvas were okay, but these weren't. These didn't fit together. I had to like come up with a solution. I tried to like make a spacer in between them, but this didn't really work. So I just thought to myself, "Oh fuck this." Had a last piece of Vuitton tubing, which was like a long one, 2 times this big. So basically, this is the half of it that's left. I swapped the little one out because as I put it on the tubing more to have the ceiling rings there, the middle one, that and it is there here. You can now better see these are the tightenings that I have told about. This basically I have the rings and I take the wire and wrap it around them so it fixes them in place to some degree. It's kind of good, so it's not totally locked in, but like 90% locked in. Let's say it that way. So yeah, so I fixed that, let's say, and I have tested out the sensors. The guvas were like lined in with the wires. This is like a fucking mess, but whatever. Let's forget that about that. Yeah, so tested it out. It worked fine. The sensors were actually reading the values. I've connected up everything on the board as well, and sucked with the insulation because I had to take it off, put it on, had to cut the wires, yeah, blah blah. So it took a lot of time. And tomorrow I will re-insulate the middle part. To then we'll test the system once or twice. Run it for like I don't know, for an hour, for let it heat up for like 30 minutes, then run it for an extra 20 minutes, put some insulation around that so it seals so it retains the heat better. Also gonna run it, so we'll gather the information to the where is it, here, yeah, this one here is the micro USB holder. So basically shield that's gonna log everything. I'm going to extract the data, then going to do maybe another run. Then after that I'm going to I have just gonna show you. It's a bit dusty, so it's not much visible, but here on the bottom you can see better. The top is like cloudy as fuck. So the bottom you can see these little BBs. Just kidding, these are aluminum beads, which are really nice little small aluminum beads, 2 to 4 millimeters in diameter, if you really want to be exact. This is going to be washed, so this dusty shit comes off, and then going to have some remaining leftover stuff here, on the shelves. So going to find the ammonium metavanadate solutions, gonna mix something out and gonna try to find it. But yeah, I'm gonna prep some ammonium metavanadate because I know I have some left that I couldn't precipitate out because it was like yeah, as you can see there is like everything here. But yeah, so I have still some ammonium metavanadate solution that is dissolved into a basic solution, basically ammonia solution. So yeah, ammonium hydroxide solution, and that's I will basically submerge these little babies in there, and then dry them, calcine them, basically cook the thing onto them, and as with heat I can decompose the ammonium metavanadate into vanadium oxides, mainly vanadium pentoxide, which will be poured into the catalyst chambers and stuffed from 2 sides with wooling. So I will have to basically take this shit off again, but at least then I will be able to like, first of all, I have some data that the system works. Now it works as well. But then the system will be better because we now have the quartz wood inside, which you probably can't really see, but maybe. Maybe I can, like, yeah. There is the quartz wool, the wools there, all three. They are, these wools contain the ammonium metavanillate, which is the catalyst material that converts the sulfur dioxide into trioxide. And unfortunately, this system is probably really good in that sense that it converts a lot because it has a high surface area. But it has multiple disadvantages, including that quartz wool has basically zero mass, thus zero thermal inertia. Meaning, if you heat quartz wool up, it will not retain its heat. The heat will be lost because as the air passes through, it basically cools it off because there's so much area and so little mass. With these, there is less space in between them, so the flow is going to be restricted. Yes, there is going to be a bigger pressure drop in them. That's like a con, but there's going to be a longer residency time, which increases the conversion, as well as there is more, probably the same amount of area or maybe even more on this. Also, it doesn't soak because the vanadium can move around on the structure, so that's not the best. As well as this is completely like, this is like heavy and has mass, meaning that it can be heated up, and this is why very important, because we have on a small scale, if we were to use or work with a bigger scale, then this would be less of a problem, because on a bigger scale the volumes are so much bigger that basically volume is proportional on the third, so it is not quadratically, how do you say this, cubically, so it is an exponential thingy, but not on the second, but on the third one, on the third power of 3 or something. So it increases with that. The surface area only increases with the square. So basically, it is only on the power of 2. So you get that x on the power of 3 is more than the x on the power of 2. As we increase the volume, the surface area doesn't increase with it linearly, so it is not proportional. The surface area is like increasing like this, the volume increases like this. So the bigger the volume, the less heat loss will be, because there is less basically surface area compared to the volume. This is why they make the systems big in the industry, so they don't have that much heat loss. So yeah, this would be not, so side point ended here, but this would be very critical here, because I'm spending a lot of energy to basically keep the thing on heat, to have it on 450 degrees, which sucks basically, because this should be economical, meaning that it should be self-sustaining, that if I heat this shit one time, the vanadium pentoxide on there produces so much heat that I would even have to cool the gases to be able to keep this shit like not overheating to a point that the catalyst conversion reduces. With this, I have to pump in so much electricity that it is not at all economical, to be frank. So this is why I will change that, but to change that will take time, and I will have to like do some chemistry stuff for now, and will not be able to build this, but as well as you will see that also, because I will vlog that here in the vlogs. So yeah, this is for today. This was a longer vid because I have compressed 2 vids into one, but whatever. So yeah, thanks for watching. See you in the next one. Do the hard work, especially when you don't feel like it.